In this section, we're going to carry on with functions. This is functions 4. We're going to look at the hyperbola in this situation. Now, you remember previously we had, let me just make a note here. This is the hyperbola. Okay, hyperbola. Okay. Now, do you remember last time we spoke about this in the last sections? We said we had a standard form. Remember, I like to work everything back to the standard form. And I say in the standard form, y is equal to a over x. Oops, and I didn't put an a, I put an x over an x. A over x minus q. Okay. Right, well, what do we mean here? Okay, we mean P plus Q. Let's just make it a plus Q, right? A over X. Sorry, I'm just going to make that a little bit better because everybody says my A looks like a 9, which it kind of does really. But A over X plus Q, what did we say? We said the graph of a hyperbola, if we remember, did something like this over here. Well, not quite like that. Let me just tidy and make it neat. Sorry guys, down, and this comes down like that. All right, and we said that this is the asymptotes, and then we went through there. This is the line y equals x. This is the line y equals minus x. This here is the lines of symmetry, and if we had A, gave us the shape, remember, and if A was less than 0, we got there, and if we had A greater than 0, we were there. So if A was positive, it's in quadrants number 1 and 3, and if it was negative, then it's in quadrants number 2 and quadrants number 4. Then we said, all right, now let's apply the Q value, shall we? What did that Q do? Once again, the Q took it up. If Q is greater than 0, I mean by that positive, okay, it lifts the whole graph up by Q. Obviously, if Q is less than 0, it drops the whole graph by the amount Q. So Q is the vertical shift of the graph. And when we lifted it up, if you remember, just to finalize our recap, we said this, okay, I took it and I said, aha, there we go, we've lifted up by Q, so now I've got a graph up here and I've got a graph down there like that. A, once again, can you see? This axis is y equals minus x plus q, and this one is y is equal to x plus q. So in essence, the entire, I'm going to call these the crosshairs, okay, where those come, you'll see in a few moments. What happens is the graph shifts up or shifts down, and the axes of symmetry go with it, okay, by the same amount. Why? Well, because that there is lifted up and it's going through that point, isn't it? Now we're going to introduce a new standard form. Okay, it's not new as much as it's just an expansion of the previous one. So let's make a note and we say the standard form here. Okay, I love my standard forms. The standard form is y is equal to a over x minus p plus q. Aha! Now let's just have a look here. The Q we sorted. The Q over there is our up or down. So it's the vertical shift. Okay. Any guesses what the P is? Yeah, it's the same. It's the horizontal shift. Okay. This is kind of getting quite tedious because they're all the same, right? I mean, what's the difference? They're all being shifted this way or that way, aren't they? Okay. Now, the same things apply, all right, except let's just think first of all. Remember let me just make a note here, back to black. Do you remember? No, don't break into song. I remember when. Do you remember when we looked at equations of the form where we had, where we had fractions? We had 1 over x minus 3 minus 1 over 2x plus 6 or whatever. What did we do when we saw those at the bottom told us about restrictions, didn't it? Whenever we see an x underneath, we have to note restrictions. I'm going to keep n being that. Because x, there's a value that x can't be. So what do? Let's go and have a look at our little our hyperbola. So let's redo the standard form. Y is equal to a over x minus p. All right? And let's just keep q out of it. Let's say plus q, but for the moment, q equals 0. So therefore, it's y equal to a over x minus p. Now, I'm going to put it into red. What happens? Remember, we took that down in a block, and we had a block, and we labeled it restrictions. Remember? And we said x minus p cannot be equal to 0. Therefore, x cannot be equal to p. Right? What does that mean? It means the value x can't be p. So what do? I draw it on the graph. Straight away, I say, hold on, x cannot be p, or x cannot be equal to minus p, depending upon what we get here with the numbers, okay? So it means that this value here is the new vertical, not asymptote, the new vertical asymptote. The new vertical asymptote, correct? That's what we've got over there. It's the new vertical asymptote. So we're going to look at these now in a different light. Let's say, for example, we have, let's take this. Y is equal to a over x minus 2. What do I say? I do my restriction. I say x minus 2 cannot be equal to 0. Therefore, x cannot be equal to 2. So straight away at the point 2, I put a vertical asymptote over there, don't I? At x equals 2. Now, obviously, if I had q, I would have a like that, wouldn't I? And q would lift it up and down. We're going to get to that one now. So, therefore, if p, if p is positive, it moves to the right. Okay? No, you don't have to remember this. It's easier to work it out just from the logic of what's happening, all right? I really, as you know, and you've been with me for a while, I'm not in favor of memorizing a lot of stuff. I like you to work it out. I like you to see it because you know what? It builds speed. You don't have to remember stuff and you don't have to run the risk of forgetting it on the day. So let's work it out. Always say, aha, I've got something underneath. What am I not allowed to be? So then you can work out the logic. So what if I had y is equal to a over x plus 4? Therefore, x plus 4 cannot be 0. X cannot be equal to minus 4. So what does that tell you? It tells you that at minus 4, I put an asymptote there. All right. And depending if a was positive, let's say a was negative, we would have a graph, doing something like that, wouldn't we? All right. If a was less than 0. Okay. Can you see the logic? All I did is I said, I remembered back to fractions and I said, what can x not be? So I did a little equation to find out where my vertical asymptote was going to be, and it's that. So if x is negative, it moves it that way. So you can work it out, really. It's not, Don't stress it. A lot of people do. It's like, I've got to remember. No, you don't. Work it out. It's very straightforward. Now, lastly, let's have a look. Okay. Just quickly, just to go over this, the standard form, let's take this graph again. They give us y is, let's see, equal to a over x plus 4. But my standard form, I always remember, we write it down straight away because we've got to manipulate it into standard form. You see that clearly in exponentials, right? Is going to be equal to a over x minus p, okay, plus 0 plus q. Therefore, q is equal to 0 in this one. Okay, just a minute. Oops, my apologies. Oh dear. Come on. Okay, I want to just tidy you up. Okay, make sure I'm back on you. Q is 0. I have to rearrange that to be y is equal to a over x minus 4. Can you see? I put it into the standard form. So therefore I know that our asymptote is x equals minus 4. So we've done it both ways, all right? It means the same, just manipulating into standard form. Okay. Now let's have a look. Okay, we say, all right, okay, I need a new page. Let's say, right, let's put it together. Okay, let's do an example together. All right, come on. Okay, remember, the whole purpose of these is we work it together. We follow, you follow, we go through it in tandem so you can see what I'm doing and then you can follow me and write the recipe down. No, sitting watching this is not going to help, I'm afraid, for maths, okay? It's practice, practice, practice. Same with physics, same with chemistry. They're not learning subjects. There's no there's recipes, but you've got to actually do it. It's a physical doing subject. Okay, now let's put it together. They say sketch the following graph, and it's y is equal to 1 over x plus 1 minus 2. Okay. Step 1, A is shape. What do? I say A is greater than 0, therefore my graph is quadrant 1 and quadrant 3. Okay, I've got that. That's my shape. Let me call this step 1, not A. I don't know why I do that sometimes. 1. Step 2, let's look at the asymptotes. Okay, horizontal is Q, is the up or the downshift. In this case, it's at y equals minus 2, correct? There it is. At y equals minus 2 is we've shifted it down. Can you see here? There we have gone down by 2 units. Okay, down by 2 units. So the whole graph has shifted down. Next step is our vertical. Asymptotes. You can just say it's going to be a restriction where x plus 1 cannot equal 0. Therefore, x cannot equal minus 1. Or you can say y is equal to a over x plus 1 minus 2. Standard form, y is equal to x minus p plus q. Okay? This is the way that I prefer it, but it's up to you. Y is equal to a over, change this, minus 1 plus, minus 2 over there. All right? Minus 2. Okay? Therefore, you can see that the asymptote is at minus 1. Right? Now, essentially, you kind of half know what this graph looks like, don't you? What do we say? We say righty-ho. At x equals minus 2, and you label it over there. and then put in the coordinate. The coordinate there is 0 and minus 2. What's the next? Am I right? No, that's y. Okay, that's y equals minus 2. And my x is going to be equal to minus 1. Okay, whoops, x at minus 1. Okay, this is x equals minus 1. The coordinates there, minus 1 and 0. I like my coordinates. Now, just as a matter of interest, this point here I call the crosshairs, okay? I'm just going to put like a little thingy. I call that the crosshairs because that's where you're moving your target. You'll see in the next ones where we start moving them, what happens to the graph if we do this. I talk about the crosshairs moving up, across, down, okay? You think of it as target shooting. The target moves, you move your crosshairs to the center of the new target. This is the center, right? And what is the coordinate of that point? The coordinates of this point here are what? But you know them. Minus 1 and minus 2. There they are. Because it's where the two asymptotes cross. That's the crosshairs. Okay, the next step in this thing is going to be what? All right. Can you see the pattern? We say, now let x equal 0. I just want to see. Let x equal 0, right? So if x is equal to 0, what is the next step? Let's see. Y is equal to a. Whoops, I forgot to put in a. Sorry, my sincere apologies. I was just keeping an a over there. Okay, let me put this back in. And it was in this case 1. Okay, y is equal to 1 over x was 0, so it's going to be 1 minus 2, so it's going to be 1 minus 2, which is minus 1. And then you write the coordinate down, 0 minus 1. So we can plot it, okay? And there it is, 0 minus 1. Okay, now, hey, come on, you can already draw this thing. You know where it is. But let's continue. What do I do next? I let y equal 0. Therefore, 0 is equal to 1 over x plus 1 minus 2. Take the 2 over and I say 2 is equal to 1 over x plus 1. You can see that. How do I get rid of this? I cross multiply again. 2 times x plus 1 is equal to 1. Therefore, 2x plus 2 equals 1. 2x is equal to 1 minus 2. All right, and let's just go further. Therefore, x is going to be equal to, well, if you like, 2x is equal to 1 minus 1. X is equal to minus a half. Coordinates, y was 0 minus a half, 0. Plot last point, and I say, oops, sorry, minus a half and 0. And it's over there. Minus a half and 0 is up there. So now I can draw my graph like so. Right, like this. Because I know it's in those quadrants. And the one coming down over there does that, doesn't it? Let's just extend this asymptote a little bit, just so we get the feel of it. And there she is. Okay. Now, the next question. Where do the axes of symmetry go? Let's explore the axes of symmetry. Green. Okay, I'm going to just roll this down slightly. Okay, let's put them in blue. Can you see there? There they are. Now we say, but hold on, what happened? The axes of symmetry have moved, have they not? But the crosshairs have moved, have they not? That is what has happened. So, in this equation over here, I say, well, where did they go? What happened? You can find them. Let us find them, shall we? You've still got that on your screen over there. So I'm going to have to use the one that I've got over here. All right. So I can say, let me just do another one, page 4. Let's just quickly sketch the graph. Whoops, wrong color. Well, not necessarily, but it's better to start with this. And remember we said over here, all right, the crosshairs, the coordinate had moved down to, over there was, let me just go find my coordinate, was a 1, minus 1, minus 2, right? Minus 1 and minus 2. I think upstairs there. Minus 1, minus 2, because this is minus 1, this is minus 2, right? So that's where my graph is now. So what are the equations of my axes of symmetry? Well, I don't know. Well, what do I know? Let's just take it step by step. What is the equation of this line? The equation of this line is y is equal to mx plus c. Is it not? The equation of this line is y is equal to mx. Do you know what? I'm going to change this to let's do this one red, shall we? Or green. Okay? This is y is equal to mx plus c. So if you're confused, we just say, but let's work it out. How? Aha! You say straight away y is equal to 1x plus c. Because the gradient of the axes of symmetry, gradient of the axes of, not that, of symmetry are 1 and minus 1 for a hyperbola. So I know that that one goes, it always goes, remember it came from the origin like this and it's moved down to the crosshairs now. So we are on the right track. Let us look. Here we go. Y is equal to mx plus c and 1x plus c. Now it goes through, but hold on, it goes through the point minus 1, minus 2. So therefore we just say, all right, therefore subs in the crosshair. Subs in the crosshair, point. Right? What is it? Y is minus 2 is equal to minus 1 plus c. Therefore, c is going to be equal to minus 1 plus 1 equals c. Therefore, the equation of that one, the one going that way, is y is equal to x minus 2 plus 1 is going to be equal to minus 1. So it's going to cut over there at minus 1. Do you see that? All I did is I said, I know the gradient is plus 1. That's not going to change. Okay, not for these. Okay, it's plus 1. Therefore, I've just slid it down, keeping it there, and I put the equations of the crosshair into the thingy. Let's look at the next one. Let's just roll you up a little bit. All right. Okay, let's look at the negative one. Y is going to be equal to minus x plus c. Put in the coordinates again. Minus 2 equals minus 1 plus c. Therefore, minus 2 is equal to 1 plus c. Therefore, c is equal to minus 2 minus 1, minus 3. Therefore, y is equal to minus x minus 3. And there are your two equations of your asymptote. Simply done. All you said is the one that's going that way is plus 1, the one that's going that way is minus 1, and subs in the equation of the crosshairs. It's simply as straightforward as that. Okay, I don't know. Really not playing ball over there at the moment. Okay. So you can see that all we're doing is we're shifting it up, we are shifting it down, all right? Let's just say over here, okay, the asymptotes they go with. Okay, the last thing they say is how do you find out where the asymptotes cut the graph? You just put the equations I just worked out equal to the graph. Remember, where two graphs intersect, you put the equations equal, the y equal to each other. Let's look at an example over here, shall we? Here's one. All right. Okay, this is quite a cool one. because it has got quite difficult bits. Let's check it out. Okay, let's look at this example now. Example here is sketch the graph of y equals minus 2 over x plus 2 minus 2. Okay, part 1 is our shape. A is less than 0, it's negative, therefore it's a quadrant 2 and quadrant 4 graph, correct? Okay, we've got that sorted. Step 2 is the asymptotes. Okay, horizontal or vertical, doesn't matter. The horizontal asymptote is going to be equal to, in this case, it's going to be equal to Q, isn't it? So there's my graph. So Q equals minus 2. Therefore, the horizontal is at y equals minus 2. Because what? We've shifted down by 2 units, haven't we? We always work from the standard one. We've shifted it down. Now we say, okay, vertical asymptotes. All right. I say, okay, from my restriction, I must say y is equal to minus 2 over x minus 2. Therefore, okay, minus 2, like so. Therefore, p is equal to minus 2. Okay. Therefore, at x equals minus 2. Correct? Because x cannot be equal to minus 2. Remember, we had a restriction. X plus 2 cannot equal 0. Therefore, x cannot equal minus 2. Right? If you prefer doing it that way. Same thing at the end of the day, isn't it? So hold on. We're almost ready to start drawing this thing. Right? Let's just continue before we do. Okay? I want to say, right, what is the next step? The next step is going to be, right, let x equal 0. I think that's step 4, is it? No, step 3. All right. Step 3, 1, 2. Okay, 3 was that. All right, never mind. Okay, let's continue. We say, let x equal 0. Therefore, you get y equals minus 2 over 0 plus 2 minus 2, which gives us minus 1 minus 2. Okay, which is going to be equal to minus 3. Write your coordinates down. 0, minus 3. There's another point to plot. Let y equal 0. A little more difficult on this sort. But don't forget, if you put all these down and plot them, you're getting marks all the way through, aren't you? Okay? You're solving for it. So that's why I say put them down and plot them. And if you can't work out the graph, do you know what? You pick a point. Try that to help. Okay? We want to get this done. We actually want you to do these. It's important. Okay? We said y equals 0. So therefore I say 0 is equal to minus 2 over x plus 2 minus 2. How do I solve this? Basically, you do it the same every time. The 2 goes over and you say 2 is equal to minus 2 over x plus 2. The next step, okay, I just want to roll it down a slight bit here. Okay, you can see it there. Minus 2 over, then you cross multiply. Okay, you get 2 times x plus 2 equals minus 2. Then you divide by 2 and you get x plus 2 equals minus 1. And you get x equals minus 2 minus 1, which is minus 3. Okay, and therefore write your coordinate down. Minus 3 and 0. Okay, well now we plot it and we draw it. Here we go. Let's plot it. Okay, I've plotted it here. All I do is I say righty-ho. Here we go. First of all, I put in my x equals minus 2. Down here like this. And I put in my cross one, minus 2 and minus 2. All right, try and get those as even as possible. Label my crosshairs, right? What are they over here? Those points are minus 2 and minus 2. Because that point there is 0, minus 2. This point here, minus 2, 0. Okay. Next, put in where I've got coordinates. I've got a coordinate of minus 3 and 0, right? So I've got a coordinate of minus 3 and 0, isn't it? That's one of them. And you can already see this is coming down like that. And this one, well, hang on. Let's see. I've got to plot another one, 0 and minus 3. 0, minus 3. And let me just extend a little bit, guys, if you bear with me. Okay, this is going down there. So we've got another graph doing this, correct? The last bit is to say, right, now let's put in the equations, or rather the It's going through here somewhere. I have no clue where they are. What are the equations of these things? Right, let's have a look. Let's have a look at this blue one up here first. We say u r y equals mx plus c. Okay, I know the gradient is plus 1. So I say that's y is equal to x plus c. Take the equation of my crosshairs, minus 2 is equal to minus 2 plus c. Therefore, c is going to be equal to 0. So essentially, I've drawn it a little bit wrong. Okay, it's going to go through at 0 over there. Okay, which you know because 2 and 2 units, 45 degrees. Over there, isn't it? Because that's 2 and 2. Arctan, yeah, we'll get to those. Okay, so that's pretty cool. What's the next thing? The next thing is to say u, what is your equation? U are also y is equal to mx plus c. What's the gradient? He's the minus 1. Minus x plus c. Equations of the crosshairs, minus 2 equals minus 2 plus c. Therefore, minus 2 is equal to 4 plus c. Therefore, c is going to be equal to minus 6. So the equation of this line is y is equal to minus x minus 6. And if you like, you can say that's minus 6 down there. All right? Minus x minus 6, or did I get that right? Minus 2. Oh, Kevin, look at me. I'm just running myself ahead, aren't I? Sorry, guys. Just correct the one mistake over there. Okay. Shows you don't try and go too fast, even your own. Minus 2 is 2. Then it goes over. C is minus 4. Minus 4. My bad. Okay. I would have lost marks for that and I'd have been furious. Minus 4. Can you see unforced errors, hey? Happens all the time. The last question they ask us is they say, all right then, what is the thing where it cuts it? Say, okay. Well, where do I go? I say, which one? Well, you look at your graph and you say, which axis of symmetry actually cuts? Don't guess, just look. There it is. It's the y equals minus x minus 4 one, isn't it? How do I find the points of intersection? They want the coordinates of the point of intersection. That's the question they're asking. How do you do that? You put minus x minus 4. It's this graph cutting there. You say then, therefore, you say minus x minus 4 must be equal to minus 2 over x plus 2 minus 2. Okay? You put those equal. That's the one that cuts, isn't it? Okay? So, once again, you don't have to remember anything. Just look at your graph. And I do apologize. I know time is going, but we're almost done with this one. Okay? What do? I get the x's. I make an arrangement. Look at the way to do it. Take the 2 over. It's minus x. This 2 goes over there. And I end up with plus 2 minus 2 equal to minus 2 over x plus 2. Then what do I do? Again, cross multiply. Get rid of the LCD or the denominator. So it's then going to be x plus 2 multiplied by, okay, minus x minus 2 is equal to minus 2. Multiply that whole lot out, all right? and you end up with this x squared plus 4x plus 2 is equal to 0. And what do? You then go and you solve that. Mine didn't come out nicely. Mine gave me x1 equal to minus 0.59 and x2 equal to minus 3.4. Okay. Right. And you'll see if you go back, okay, let's just go and plot. You get 1 over here, where this one over here, the x coordinate there was the minus 3.4. Can you see it? That's there, that coordinate there. To find y, you just back subs into the easiest one, correct? And this one over here, the x coordinate down here of that point is minus 0.59. And you'd find the other coordinate by back substitution. Okay? And I'd say find y1 and y2 by back subs into which one? I would take y is equal to minus x minus 2 to find the values. You end up with y equal to, for that one, you end up minus 3.41. And y2 over here, minus 0.6. So my coordinates are minus 0.59, minus 3.41, and the other point of intersection are minus 3.4 and minus 0.6. Can you see these numbers here are basically the same numbers? They've just flipped, okay? Which is what you'd expect because they are rotated, aren't they not? Okay, about the line y equals x. That, in essence, is what we're going to do with these. There are, as I say, the next step, the next one's got more examples of this. Just go through and work through these with me, and you'll see they're actually quite straightforward, because what's going to happen is at the end of this section of functions, we're going to put it all together, and you're going to have a parabola cutting through a hyperbola, or an exponential cutting through a parabola, and we're going to have to work out points of intersection, axes of symmetry, etc. So it's worth getting these basics down, okay? No, I haven't picked easy ones that sort of round off to nice numbers on purpose. Cheers, have a great one, and I'll see you in the next session on functions. Cheers, bye.